Right, we're going to work through some practice problems today in our section about learning loops. And so we'll start here with number 1, which is to write a program to calculate the sum of the first 10 numbers. Right, I'm just going to pop up code blocks here. Right, all I've done was created a project with code blocks, created a file named practice1.c, and copied the problem statement into the file. Right, so if we want to calculate the sum of the first 10 numbers, there are different ways we can do this. We're going to assume the first 10 integer numbers. Right. And let's go ahead and display that sum. We can see what it calculates. So I'll include standard io.h. So I'll probably end up using printf. Create our main function here. All right. We want to avoid doing something such as int sum equals 1 plus 2 plus 3 plus 4 plus 5 plus 6. You get the idea. If I can type. Notice I've started with 1 and not 0. All right, some of these first 10 numbers 1 through 10. Well, we could do this, right? We could just print it out and say sum of first 10 numbers is, and print out the sum. Right, if we build and run this, right, we get that the sum of the first 10 numbers is 55, starting with 1. All right, well, that works for 10 numbers. Right, but what if we want 100 numbers? We don't want to type in 100 numbers. I don't want to type in 20 numbers. I want to use a loop. Right? I want to generate the numbers 1 through 10 in my loop, and I want to keep adding to the sum inside the loop. Right? So I'm going to comment that out. Right, that's what we were doing before. I want to declare sum, and I want to initialize it with 0. Now, let's use a while loop. And what we want to do is, right, let's create then our, I'll call it number. Let's start number with a number 1. We're going to say while number is less than or equal to 10. So when we write a loop, in the parentheses here, we put a test condition, right? As long as this test condition is true, it's going to perform the statements in the body of the loop. The statements in the body of the loop are going to be inside these curly braces. So in here now, if I say sum equals sum plus number, I'm going to generate then the sum of the first 10 numbers. And let's walk through this with a debugger. So I'm going to put the cursor here and right-click, do a run to cursor. It's going to rebuild. It's going to bring up my watch window here. Right. And so now it's executed the code before the while statement. The yellow triangle indicates that it's executed all the code up until this line. We can see sum's been initialized to 0. Number starts at 1. And so now if I say next line, what it's going to do is it's going to evaluate this test. Right? While number is less than or equal to 10. Well, we can see that number is 1, so while 1's less than or equal to 10 will be true. So we'll come into this loop and perform that statement. So that was true. Right? You can see we've gone into the loop, so now we're going to take what's stored in sum right now. 0 is what's stored in sum. Going to add what's in number, 1, and then store it back in sum. So we'll see sum becomes 1. Sure enough, sum changed to 1. Now, number didn't change, did it? If I were to keep running this, notice this would be what we call an infinite loop, right? Number is never changing. This test condition is always going to be true. So all I'm doing is adding the number 1 to this forever and ever. We need to do something else inside the loop. we need to increment number. I'm going to stop the debugger. And what we can do here is we can say number is equal to number plus 1. And now let's do run the cursor. So we rebuild. All right, we're starting over now. Sum's been reinitialized to 0. Number's going to start at the number 1. We're going to see that we're going to memory to retrieve number. We're going to compare number. So 1, what's stored in number, less than or equal to 10 will be true. We'll drop in here. We'll add number to sum. So 1 plus 0, assign it back to sum, becomes 0. Now when we increment number, right, numbers become 2. So this test is now performed. While 2 is less than or equal to 10, well, that's true. Go into the loop and perform the statement. Right, so now we're going to take 2, add it to 1, and store that back in sum. Sum will have 3. We're going to increment number. Right, so it becomes 3. As you can see, we can just keep stepping through here. Right, watch number go up by 1 every time. We keep accumulating the sum of each number, storing it back in sum. Number's 9. All right, now number's 10. This will still be true. Right. Now, when number's 11, this condition will be false. So you're going to see we're going to come down here and execute this statement. So next line, sure enough, we bypass the statements in the loop. All right, if we press this, we'll see what it does is it displays that our sum is 55. Right. A loop is a very powerful construct. And think about it. Now, this test condition, if we wanted to sum the first 100 numbers, all we need to do is change that to 100, right? Build and run. And we get the sum of the first, well, I should change my message because it says first 10 numbers is 50-50. All right, so I should change that message. As a matter of fact, I could use something like a preprocessor directive. And I could say pound define, I'm just going to call this limit. And if I define the limit as 10, so now I'm going to substitute limit here. So the way a preprocessor directive works is everywhere I use limit, it will just substitute in the number 10 at compile time. So %d. So I want to print out limit and sum. Right. And let me give another new line before this so our output's a little bit easier to see in the console window. So sum of first 10 numbers is 55. Right, it substituted my value for limit in here, changed my message, it controlled my loop where my loop ended. And now, if I change limit to 100, that's all I have to change in my program by using this preprocessor directive. Here, this macro, everywhere I use limit, the compiler just substitutes in, hard codes in the number 100 at compile time. So 100 is put here in your program and here as a constant, integer constant. Right, some of the first 100 numbers. Right. If I wanted this to be 37, if I wanted to sum the first 37 numbers, 1 through 37, I'd have to rebuild when I make that change, but now we get that. So this is a pretty powerful construct, using macros or constants to define information to make it easier to change your program, but the loop lets us repeat sections of code over and over, which will become very important as we progress in our programming skills. And so we've done this now with a while loop. Let's take a look at how we could do it with a for loop. I'm just going to comment out this section here. All right. It's always important that we initialize sum to 0. I didn't mention that. I initialize sum to 0 because we wanted to have a starting value in sum. And we know that if we add 0 to anything the first time, we're just going to get back that first number. If we don't initialize sum, remember sum will have garbage in it. We don't know what we'll get for certain. All right. So this is a a while loop implementation. Let's go ahead and see what would happen if we code this with a for loop. All right, so there's some different ways we could do with a for loop. Let's go ahead and declare number as a variable. I'm not initializing it to anything. Here in my for loop, I'm going to say for number, I want to assign to that the value 1, while number is less than or equal to limit. And then number equals number plus 1. In here, I just say the one statement in the body of the loop is sum equals sum plus number. Let's talk about for loop syntax. Typically in a for loop, in all the statements to the left of this first semicolon, we initialize variables. We give them a starting value. Right? In this case, I'm setting number equal to 1. When a for loop executes, these statements here to the left of this first semicolon execute once and only once. Very similar to the way that we initialize number to the value of 1 up here, so that when the while loop started, the first time number was equal to 1. So it's important to remember these statements, because we can have multiple statements, but this statement here to the left of the first semicolon executes once and only once at the start of the loop. The next thing that happens is this test is performed. It checks to see if number is less than or equal to limit. As long as the test condition is true, then it will execute the statements in the body of the loop. Statements in the body of our loop are contained within these curly brackets. Very similar to the while statement, right? We initialize number up here, then the test condition was performed. When the test condition was true, we executed the statements in the body of the loop. But notice with a for loop, the only statement we have here in the body of the loop is summing the numbers, right? Sum plus number and assign it back to sum. Because when the loop finishes, it loops back up then and performs this statement. It goes ahead and it adds 1 to number, reassigns that. So in the same way we perform this statement here at the end of the while loop, we perform this statement here in the for loop. And then it goes back and performs the test. So it's going to increment number by 1 as long as number is less than or equal to limit. So remember, as long as the test condition is true, it performs these statements in the body of the loop. Let's just step through this one now and watch it perform the same actions. All right, so we've got number. Notice number hasn't been initialized, so in my system it just decided to assign the value 8 to it. That's what happened to be in memory, in that memory location. Now if I say next line, right, what it did was it initialized number to 1. That happened first. Then it compared number to limit. This was true. Number was less than or equal to limit. In this case, I didn't change the limit from 37, so we probably won't step through here 37 times. But if I hit next line, notice that we took what was stored in number, the number 1, added it to sum, right? Sum had the value of 0, and then reassigned it to sum. Right, so we've added 0 plus 1 so far. Now what's going to happen is when I hit next line, we're going to see that number is going to increment by 1, number will become 2. It will pass this test, and our next statement of execution will be here inside the loop. So next line, notice number is equal to 2, right? It passed this test, so it's ready to execute this statement. Right? And so that's the way it cycles through. We'll execute this statement, it'll come back here, perform this statement, then perform the test. As long as the test is true, right, it will then perform the statements in the body of the loop. So we could step all the way through and watch sum and number keep increasing. Right. Like I said, I don't necessarily want to go all the way up to 37. So what I can do is I'm just going to put my cursor down here and say I want you to finish the loop and go ahead and print out that information. So if I say run to cursor now, right, I've just performed all those actions and printed out my information there. Right. So that's a way we can do this with a for loop. Right. The for and the while loop work very similarly. It's just that with a while loop, we have to initialize, usually our test variable has to be initialized before we perform the test. That makes sense, right? We need to have a known starting value before we perform the test the first time. In a while loop, we do it outside the loop. In a for loop, we typically do it right here in this statement. We increment numbers in the for loop over here, the numbers that control the number of times that execute the loop. In a while loop, we have to do it somewhere within the loop before we loop back up to the test condition. All right, so there's our example of summing the first 10 numbers, or however many numbers you want to sum. Lastly, what I can mention is we don't have to declare this outside here. By C99 standards, we can go ahead and declare this variable here, number. And so let me compile. Now you have to have a flag set for the C99 compiler. Mine is still I'm not quite sure. Build and run. Maybe I didn't hit compile. All right, so build and run, because I've got a flag turned on that recognizes the C99 compiler. All right, so I can declare variables within here. Right. Because this action happens once and only once, it declares this, initializes it, right, and then runs through the loop. What we should know is when we get outside this loop, so when we get outside this loop, so here I'm going to say run to cursor. All right, so notice number has not been initialized yet. It still has that same value of 8. Right, if I just hit next line, number gets initialized, this test was passed, it's waiting to perform these actions. Right. It'll keep looping through in the same way it did before. I won't go through all the looping steps. But what I'm going to do down here is, I'm going to say run to cursor. Notice outside the scope of these curly brackets, number has disappeared. It's important to know that when you declare a number within a loop here, it only exists in memory. You only have access to it as long as the loop is running. Outside the loop, outside the scope of these curly brackets, number no longer exists. So I could not use that variable somewhere in my code. If I hit stop the debugger, for instance, out here, if I tried to, for some reason, just assign some value to number, and now I compile, I get an error message. Error, number undeclared first used in this function. That's because I declared number here. Once this for loop gets done, this variable that I declared here is no longer in existence. It's no longer in scope. I no longer have access to it. Right? It's completely different if I declare number outside here. So if I declare it here, then I can use it anywhere within me. Right? If I compile, that works as well too. So I show you some of these errors because they're typical things that as you're learning to program, you'll do, and you'll wonder why you're getting that error. And sometimes, to be honest, I make those errors as well too, because I don't pay enough attention to what I'm currently doing. All right, but they're easy to fix once you get to know how the program works, right? How the C language works, and what those compiler messages are telling you. All right, so that is the end of this practice example.